Hi everybody, we're going to talk about section 1.3.2 in your integrated 2 textbook, and we're using the properties of this parallelogram and the rigid transformations that we've already discussed to come up with some really interesting things. Like, what is the relationship between this angle and this angle, this angle and this angle, or opposite angles, okay? So this section has you start off by creating a tile pattern using a parallelogram and some of those rigid transformations. So I'm going to do that by using, at first, just a translation. So I'm going to take this parallelogram and I'm going to slide it right over here. I'm going to translate it to the right next door. I'm going to take another one and I'm going to translate it to the left, right next door. And you can see now that I have 3 parallelograms. They're all the same size. I know that they're the same size, translating one up and one down, because we did a rigid transformation called translation. And a rigid transformation, by definition, does not change the size or the shape. All it does is move it somewhere or somehow. So we know that all of these parallelograms have to be the same size. And if you're not sure, you can take your original one back and just kind of line them up on top of it and see, are they still the same? Yep, everything's still the same. There we go. Okay, so let's see what that means about the angles that you're looking at. So see this little red angle here that's marked in the right upper corner of my yellow parallelogram. If I take that and I translate it back on top of my center parallelogram, you can see that that angle still lines up perfectly. And if I move it over to this one, it still lines up perfectly right here. It also lines up here and down at the bottom. That's great. That tells me that all of these angles that are in the same position on the parallelogram, corresponding angles is what it's called, are equal or congruent. All right, so let's take this, line it up, and do a rotation now instead of a translation. If I rotate this thing 180 degrees, my red marked angle ends up on the bottom. Sorry, one more time. There you go. It ends up on the bottom of the parallelogram. So I went from up here to down here. But if you'll notice, that angle is still the same measurement. And if I move it up here, again, it's still the same measurement with that parallelogram and that parallelogram and this parallelogram. So what that tells me is that all of these angles in this corresponding section are also the same as this angle here. So my opposite angles, just to show you one more time, have to be congruent to each other. And it's not just for this one parallelogram, it's for all of them, since they're all created from the same one to begin with. They're all copies of the original. That's a really interesting thing when you start taking this thing apart and you want to talk about what is this angle here versus this angle here. We do some combinations of angle pair theorems that we've talked about, like vertical angles that are congruent, like a straight angle pair has to equal 180 degrees, or supplementary angles when added up equal 180 degrees. You can use that information to help you find missing pieces. And we'll talk a little bit more about that in another video. I'm going to give you a real quick rundown of one of those problems just to help you if you get stuck.